What's up, everyone? Welcome to Maths with Gastin. I am Gastin Mapala, right here at Maths with Gastin. Today, let's have a look at past papers. Most of you guys have been asking me when are we going to start doing past papers. We have not done Euclidean geometry and also financial mathematics, but does that mean that we can't do past papers? But here we are on paper 1 of November 2022, number patterns. This is a grade 12 paper. It was question 2. So what we're going to do, we're going to put out a series of question 2s on November question paper of 2022, 2021, and then 2020 as well. So please make sure that you subscribe to this channel so that you can also see those videos. We are going to do all the past papers, but we're going to go through them accordingly, question by question, so that we are able to understand each and every concept and how the examiners are asking questions. So now here is the question, is question number 2. Please take a screenshot, have a look at it, or if you have a past paper, let's go through it together. What I'm going to do, I'm going to do question 2.111 and 2.2, and then do the other two as we continue. Okay, all right, so let's have a look at 2.1. It said the first term of a geometric sequence. This is very good that they are telling us that this is a geometric series. Rather, it's 40. Okay, so they're saying this is the first term. The first term. Normally, the first term, a geometric sequence is given by TARN minus 1. Okay, so now they are saying this is the first term. Okay, so let's have a look at the first term. On our first term, it's 14. Okay, first term is 14, and then the sixth term it's 448 rather. Okay, so now what we're gonna do now, we're gonna go through the first question. First question 2.11, it says calculate the ratio, which is R. Okay, so let's go ahead and deal with the question number 2.1. 2.11. The question here is saying, why calculate the value of R, which is the ratio. Okay, so now let's see how we're going to deal with one. Since we're given that the first term T1 is equals to 14, that is given to us, and also T6 is equals to 448. Okay, right? So now let's see how we're going to deal with this one. We know that T1 is given by ARN minus that, but we know that N is equals to 1. Okay, all right, so let's come here and substitute that R is equals to 1. So excuse me, so I'm going to take this one here. So it's going to be 14 is equals to A, which is equals to R1 minus 1, which is going to give us AR to the power of 0. We know that everything to the power of 0 is going to be 1. So it's going to be 14 is equals to A. R to the power of 0 will give us 1. Therefore, A in this instance is going to be 14. Okay. All right, so we have got that 14 is A is equal to 14. So from the equation there, they also said T6, which is this one there, which is 448, should be equals to AR, where N it will be equals to 6. Ne? This is given on the equation that is equal to 448. So N will be 6 minus 1. I'm just substituting here on this general formula, guys. This formula is on your formula sheet. If you are getting lost, please make sure that you subscribe to this channel and then watch our lesson video on sequence and series and number patterns as well. Okay, so that's the formula we're using there. So therefore this should give us A is equals to R to the power of 5. So we know the value of A, so it's going to be 448 is equals to A, which is 14. R is going to be 5. Okay, so if you divide both sides by 14, because now the question says we must look for R, divided by 14, then you are just going to take the fifth root. R is going to be equals to fifth root of 448 all over 14, which will give us in put that in your calculator. You should be able to get R is equals to 2. Okay, so we managed to get that R is equals to 2. Therefore, you should get your marks there. R is equals to 2. They say 2 marks. Okay, all right. Excuse me. I know there are many ways of dealing with this, guys. If you know any other way, please make sure that you leave it on the comment section below. We'll definitely there are many ways to kill a cat. All right. Okay, so now let's go to 2.1.2. It says determine the number of cons determine the number of cos determine the number of consecutive terms that must be added to the first 6 terms in the series in order to obtain a sum of 114674. Okay, so what does this mean mathematically? This means what they are saying immediately when they say sum, we go and look at the sum formula where r is greater than 1. So which formula do you use when r is greater than 1? The S formula that you use when r is greater than 1. Go there on your formula sheet, guys. Is there is Sn is equals to, let's just get it down here, arn minus 1 all over r minus 1. Okay, so this is the formula that we use because we know that our r is equals to 2. We have calculated it previously and is greater than 1. Therefore, this is the formula that we use. So we've got the right formula. So now let's read. So they're asking us how many terms. So it means how many the number of terms that you need to add to the first 6 terms in order to get the sum of 1164. So therefore, basically what they are asking us is that they've got the first 6 terms, term 1 up until term 6. Okay, therefore you must add something here so that you get a total of 11467. Just to put that into perspective, guys, so that you understand what they mean. Okay, so they are asking you, so how many terms are here? So let's say you already know the sum of the first 6 terms. So now they're asking you how many do you have to add here so that you get this sum. Okay, all right, great stuff. So now we already know the sum. They gave it to us here. This is Sn. So we already know what is A. A is given by there. We have calculated it. A is 14. And then we also know R is equals to 2. So let's go ahead and look for N. So 114674 is equals to A, which is 14, all over r, which is 2 to the power of n minus 1, close bracket, and therefore r is 2 minus 1. Okay, so therefore excuse me, therefore 2 minus 1 will give us 1. Then we do cross multiply. This is as good as over 1. When you cross multiply, you are going to have 14, 2 to the power of n minus 1 is equals to 114674. Rather, therefore, we must divide both sides by 14. Okay, we divide both sides by 14, divide both sides by 14, and then we this and this would cancel out. Then we take n that side. Therefore, we are going to be left with n. It's 2 to the power of n. It's equals to 114674. You can see, guys, by all means, I'm trying avoiding using a calculator so that I don't make mistakes. Okay, because most of the learners, what we realize is that immediately when they touch a calculator, you lose a step. Okay, so I'm trying by all means to avoid using the calculator for now. Therefore, there it is. So if you go and punch this in your calculator, okay, let's go ahead and do that. When we punch this in our calculator, we should be able to get that 2 to the power of n is equals to 8192. Okay, therefore it means let me just write down this properly so that you can see it. because most of my learners, when I put double equal sign, they complain a lot. Okay, so once it's like this, guys, because in grade 12 we don't do log anymore, but at some point we need to apply them. Okay, so for now, what I need you to know is that when you log, let's say you've got x to the power of 3 is equals to some number here. Let's just say maybe it's equals to 100 for argument's sake. If you decide to put log here and then you also put log this side, okay, log 100, okay, what I need you to understand is that if you put log and then you've got a power, you need to drop that power. So what else is going to happen what do I mean by say drop? You must take it to this side. Okay, so you are going to have 3 is going to come down. It's no longer going to be the power x, is going to be log 100 in this side. Okay, so having that in mind, let's log both sides here so that the n can do, we can drop the n can come down. Okay, log this side and then it would also log this side as well. Okay, okay, let me just see, I didn't put enough space for myself here. Okay, but for now, let me just do this, remove this 181 so that we can have space, and then I can say log 8192. Okay, so with this, okay, this is in bracket. Okay, with this, now because you've logged both sides, you can now drop the exponent. You're going to have n log 2, it's equals to log, please don't punch this on a calculator yet. So you are looking for n, so what you would do, you would divide by log 2 both sides, divide by log 2 both sides. Okay, cancel out. When you put this on your calculator, you divide by log 2 both sides, you should be able to reach an answer of 13. Okay, however, guys, we have not answered the question. Says determine the number of consecutive terms that must be added to the first 6 terms. So this is the total number of terms. Therefore, the total number of terms is what? Is 13. N is equals to 13. So you need to remove the first 6 terms in order for you to get to see how much was added on the first 6 terms. So if you say 13, you minus 6 from 13, you should be able to get 7. Therefore, what's your answer? Your answer is 7. So 7 more terms need to be added in order to get a sum of 114,674. I hope you understand it, guys. If you don't understand it, make sure that you leave the comment on the comment section below, or reach on us on our WhatsApp number so that we will be able to assist you if you need assistance one-on-one. Okay, so let's go ahead and do the rest of the question. Rest of the question is 2.1.3. It says if the first term of another series, okay, please listen very carefully. It's saying, let me just put it down here. The solution said if the first term of another series, therefore it means this is the first term, so this is T1. It's 448, and the sixth term, so this is T6, it's equals to 14. They are saying calculate the sum to infinity. Okay, so same thing would apply what we did previously. We have got our formula here. Tn is equals to Arn minus that. We know what is T1. T1 is what? We're going to substitute it here. T1 is 448. It's equals to R1 minus 1. Therefore, we know that A to the R to the power of 0 is equal to 1. Therefore, this leaves us with A being equal to 448. Okay, I hope you guys can really follow. This is just a repetition of what we did earlier on. Okay, so therefore, having this in mind, we can go ahead and we say, okay, now if T6 is equals to 14, therefore, you should be able to be having A R6 minus 1, which is going to give you A, which is, we know A, let's rather substitute A here instead. 8, and then r is equals to 5. Therefore, you've got 14 there. You divide both sides by 448. 448. Therefore, you're looking for r. You're going to take the fifth root of r, where it's 14 all over 448. This should give you how much. If you were able to punch this in your calculator, it's just going to be the opposite of what you calculated earlier. It should be able to give you half. Okay, so therefore the excuse me, the question says find the sum to infinity. So if you go to your formula sheet, guys, you look at sum to infinity. Sum to infinity says, and according to our lessons, we only use the sum to infinity formula if r is less than 1 but greater than -1. And in this case, it is correct. R, it is half. Therefore, it is less than 1 but greater than -1. Therefore, we can use this formula. Sn is equal to a all over 1 minus r. Okay, we know what is a. A is given to us by 448 all over 1 minus half. Okay, if you go and punch this in your calculator straight away, guys, from here we only gonna mark you on your substitution. So definitely just punch this on a calculator as it is. Therefore, you should be able to get that the sum to infinity of this series is 896. Okay, great stuff. All right, guys, now let's go ahead and do question 2.2. 2.2, it's sigma notations. I know some of us we struggle with sigma notations a lot, but let's try to unpack this one. It is saying there, if you've got the sum of 1 over 3p plus 1 over 6 in close bracket, where p starts at 0, you should be able to get the sum of those terms, rather, to be 21 over 6. Right, great. Okay, so now they said the question there, it says we must need to determine the value of k. What is the value of k in this case? This value here is just referring to the number of terms. Okay, don't be confused, guys. This is referring to the number of terms that when you add them together, they give you this sum. Okay, so therefore this is the what? This is the total sum. Okay, right. So now let's come here and look at this one here now, which is a 2.2 rather. Okay, so let's come here and have a look at 2.2. Okay, let's come here. I'm just checking something here, guys. All right, great stuff. Okay, let's have a look at 2.2 now. Let me just put a line here. Okay, what we're gonna do first now, we are going to substitute, guys. Be very, very, very careful. The examiners, they do this on purpose. Okay, p, the question says p must start at 0. So it means when p is equals to 0, what you're gonna have? You're gonna have your t1. Okay, so let's substitute here half 1 over 3 rather, p is equals to 0, okay, plus 1 over 6, okay. So t2, it means you're getting t2 when p is equals to 1. So you're going to have 1 over 3, 1 plus 1 over 6, okay. T3 is going to be 1 over 3, and then you're getting it when p is equals to 2, okay. So you are going to have 2 plus 1 over 6. Therefore, if you were to go and put this in your calculator, the first one you should be able to get 1 over 6. Therefore, the second term you should be able to get to half. And then for the third term, you should be able to get 5 over 6. Okay, all right. So now, if you were to look at these terms here, and then you check T1 over T2, you will realize that it's not a geometric sequence. Okay, so now we need to have look at the other terms that we are familiar with. We need to check if this is an arithmetic sequence. Okay, so if you come here and you say term 2 minus term 1, so term 2 minus term 1 is giving us 1 over 3. If you look at term 3, which is 5 over 6 minus half, you should be able to get 1 over 3. So therefore, this gives us the first difference, and we know if we deal with the first difference, therefore, this therefore becomes an arithmetic sequence rather. Okay, so therefore, this is an arithmetic sequence. So what we're going to do now, because it's an arithmetic sequence, we have got the total sum. What we're looking for is the number of terms that will give us a total of 21 over 6. Okay, so we know the formula of arithmetic sequence, the sum of arithmetic sequence. There's two of them. The other one is where the last term is known. The other one is where the last term is not known. Okay, so we are going to use this formula now. Sn is equals to n over 2. Check your formula sheet, guys. 2a plus n minus 1d. Okay, all right. We already know I have the total sum is right here. It's given to us. So here you are going to have 20 when you're substituting 1 over 6 is equals to n. We don't know what is n because we are looking for n in this case. Okay, all right. So now, excuse me. All right. So you're going to come and put 2 here. Therefore, 2n, we don't know what is n, plus n minus 1, 1 over 3. Okay. So that's how you would substitute here. But what you're going to do now, you're going to try by all means to make, let me see, to make, gonna try by all means to make n the subject of the formula. Okay, so if you put this in your calculator, you should be able to have in 1 over 1 2 1 all over 3. Okay, so it's equals to n. Okay, then you multiply everything by through, you remove the bracket here. Okay, let me rather not remove the bracket now, guys. This is just algebra. You come here and you come here and say, you're gonna come here and say plus 1 over 3 n minus 1 over 3. Okay, so you put this, all of this in the calculator, guys. You should be able to get to an answer of, I have run out of space there, guys. You can come and put in 1 over all over 3 is equals to 1 over 3 to the power of 2. Once you have got that, then you can therefore multiply by 3 both sides. Multiply by 3 both sides. Therefore, the 3's would cancel out. Therefore, you're going to have n squared is equals to 1 to 1. Therefore, you take the square root of 1 to 1. N should give you, let me see, n should be able to give you 11. Okay, but the question asks us to calculate k. Okay, so k would be 1 less, because remember, a p, it's starting at equal to 0, so therefore the value of k should be equal to 10. Okay, all right. But however, guys, there's many ways to kill a cat. There's other ways of how you should be able to deal with a question like this one. Please let me know if you want us to do the other way around and see how we can be able to deal with this one. I am Gaston Mapala. Please stay tuned to this channel. Next time, on the next upload, we will be doing November 2021, but we are still on question 2. Right. Okay. See you on the next upload. Please make sure that you stay tuned on Maths with Gaston.